Okay, Math 9, let's get after it. We have a short here for two of our exponent laws, power to a power and zero power. There are a few interesting pieces to this, and they will get more involved as we increase the difficulty. So here's just a short on these quick two concepts. So for power to a power, it's a little bit more confusing when you're asking that forever positive or forever negative question. Because we know that for power to a power, or we know from the full lesson, we'll talk about it a little bit further, you would multiply your exponents together. So in that case, 2 times 3 is 6. And then 6 is an even number. So people might be thinking, well, I have an even exponent and it's in brackets. It's got to be positive. But the thing is we don't actually know if it's going to end up looking like this or like this, right? Because you have a negative 3 in here to the 2 and then multiplying it by 3. But does that mean it looks like this or does that mean it looks like this? So in order to alleviate that pain and to determine whether or not this is going to be positive or negative, look at the inside of the brackets, but you only have to do that once you've looked at the outside exponent. You see here the outside exponent is odd, which means that if you have a negative number inside the brackets, you'll have a forever negative. If you have an even power out there, like this one, then this is forever positive always. It doesn't matter what's in here, because even if that's a negative number, it's to an even outer power. So you only need to look at the outer power. So since this is an odd number, this is going to be forever negative because the inside is forever negative. Because it's a negative number to an odd power, which means forever negative. So in this case, we would have a forever negative scenario. If you look at the one on the right here, though, this is an even number. So it doesn't matter. Even if it's a negative, you have a negative twice, which is going to make a positive. So look at the outer exponent. That's the important one, the outer exponent. If it's even, forever positive always. If it's odd, you got to look at the inside. Okay, so now let's look at it in play here. Power to a power, we have 2 to the power of 2 4 times. That's what power to a power means. And we've seen this before because now we're multiplying a common base and we would add our exponents. 2 plus 2 plus 2 plus 2. Okay, but addition, repeated addition, can be simplified by using multiplication, 2 to the 4, or 2 times 4. Sorry. So that's what we do here. We take this and we have power to a power. So we have 2 to the power of 2 times 4, which becomes 2 to the power of 8. Seems pretty easy because it is. Now, when you have a fraction, consider that means you have this times this times this. And with multiplication of fractions, it's tops with tops, bottoms with bottoms. So in this case, we'd have 2 times 2 times 2 over 5 times 5 times 5, which means we have 2 to the power of 3 over 5 to the power of 3. So what happened there? Well, this exponent still multiplied with the exponents of our whole numbers. In this case, they're both ones, but they multiplied with both the numerator and the denominator. So if you have power to a power, but you have addition, this is where there's some serious pitfalls in math in the years to come. You most definitely cannot do the power to a power rule with addition. That's a no. Do not do that. You have to treat this like bed mass. So you have to solve the inside and then you have the power. So this is just 25. When it's addition or subtraction in here, you must do it that way. If you have multiplication in here, it doesn't matter. Because watch, if we did 2 times 3 is 6, 6 squared, we get 36. If we multiplied the 2 in and did power to a power, you'd get 2 squared times 3 squared, which is 4 times 9, which is 36. So if it's multiplication in there, you can do the power to a power, but you could also just multiply the numbers together. Where things get a little bit more challenging is when you have variables inside. And this is the sort of statement you'll see in grade 10. This is the type of statement that you are not allowed to do that. No. You have to do that. Yes. But think about, wait, I have an X in there. I can't even add these things together. So you'll learn in about a year how to deal with that. But just remember that you cannot do power to a power across addition. That's a no. All you can do is simplify the inside first. Now, what about zero power? Well, follow this logic here. 5 to the power of 5 means 5 times 5 times 5 times 5 times 5. And then to the 4, and then to the 3, and then to the 2, and then to the 1. And if you think about how you got from here to here, well, we lost a factor of 5. We don't just lose them, we divide by a factor of 5, and then we divide by a factor of 5, and then we divide by a factor of 5, and then we divide by a factor of 5. So what happens when you divide by a factor of 5 here? What's 5 divided by 5? Well, that must mean that 5 to the power of 0 is 1. So anything to the power of 0, except 0, is 1. Now, obviously, there's going to be a negative caveat in there, but we'll look at that. But here's another way to consider it, using the other laws that we've learned. I'm sure you can agree with me that 5 to the power of 8 over 5 to the power of 8, that's division of a common base, so we would subtract the exponents. So you could agree with me that that is an equal statement. Subtract the exponents. Well, 8 minus 8 is just 0, so I'm sure you agree with me that that is an equal statement. But if you consider that 4 divided by 4 is 1, and 5 divided by 5 is 1, and negative 72 divided by negative 72 is 1, anything divided by itself is 1, well, that's what you have here. You have the same thing divided by itself. So that means that it is equal to 1. And if you have things that are all equal to each other, you can erase any of them, and anything remaining will still be equal. So it means 5 to the power of 0 is still equal to 1. So anything to the power of 0 is equal to 1. Now, classic, watch out for those negatives. This is forever positive. Everything in the brackets is to the power of 0, so the answer is just 1. This is a forever negative statement, which means we have negative 1 to the 4 to the 0, which means we have negative 1 to the 1, which means we have, not to the, but times negative 1. So watch your negatives. So again, we're watching our negatives. They're pesky. Power to a power, 0 power. Don't forget the bed mass. Cannot water power to a power when you're adding or subtracting numbers. Quite a bit to go on here, but watch the videos, try the full lesson, and don't forget to refer to your notes, section 2.3. Okay, great work. You're crushing it.